There's a pattern in how you add things in series and in parallel. Resistors and inductors add the same way. Capacitors and springs add the same way, and the way they add is opposite each other. You use a formula like this or the formula like this. You simply add them or you add them upside down. Here's why. When objects are in series, you're adding their lengths. When objects are in parallel, you're adding their areas. When area is on the bottom, if you want to add areas in parallel, you have to flip this over. And so resistors add upside down in parallel. But the length is on top, so resistors simply add in series. Capacitors are the other way around because A is on the bottom here, A is on the top here, L is on the top here, D, which is like length, is on the bottom here. A spring acts like a capacitor because if you expand the spring constant into the materials, Young modulus, area, and length, you see that area is on top just like a capacitor, length is on the bottom just like a capacitor. There's one loophole in this. Inductors, for some reason, have inductance proportional to area as well as to length. So they're proportional to length, so if you add them in series, they add. But it turns out they add like resistors do. They add inversely in parallel. This formula does not say why that happens, and I haven't figured it out yet. So there's a mystery. One last place that this shows up is in astronomy. If you have two gravitational masses and they're in the same place, you simply add their masses. But if the two masses are separated and you're trying to simplify the mathematics, you calculate what's called the reduced mass, mu, and you simply add the masses upside down. So this pattern recurs in lots of different areas.